Today I'd like to go over some of the properties of logs. There's several properties, but we're going to look at three primary properties today. So to start, let's go and look at a couple examples that we're familiar with already. We have log base 2 of, say, 4 plus log base 2 of 16. We want to find what that's equal to. Well, log base 2 of 4, we look at that, it says 2 to what power is equal to 4? We know that's going to be 2. So log base 2 of 4 is 2. And for log base 2 of 16, this is 2 to what power is 16? We know that's 4. So we know 2 plus 4 is going to be 6. Going back to the original problem, if we have log base 2 of 4 plus log base 2 of 16, that's going to be equal to log base 2 of 4 times 16, which is log base 2. 4 times 16 is 64. And this says 2 to what power is 64? Well, that gives us the 6. So the idea here is that when you're adding two logarithms and the bases are the same, that's key, the bases has to be the same, we can rewrite that as a logarithm of the two numbers we're taking the log of multiplied together. So log base 2 of 4 is the argument in this one, 16 is the argument in this one. We can multiply those two arguments and rewrite it as a single log of those two arguments multiplied together. And that has to do with the properties of exponents. If we take this expression, these two expressions here, and do 2 to the x times 2 to the y, we know from properties of exponents that's 2 times the x plus y property. Remember, logarithms are exponents. So if you think of this as x, think of this as y. Here we're adding x and y. Here we're adding x and y. So that's the idea with properties of logs. One of the properties of logs is that if you're adding two logarithms, you can rewrite them as a product of one log. So for this example, log base 10 of 200, log base 10 of 5, that gives us log base 10. 200 times 5 is 1,000. And if we want to evaluate that, that says 10 to what power is 1,000. And that gives us 3. By the same token, when we add add logarithms and the bases are the same, we multiply the numbers. If we're dividing or subtracting logarithms and the bases are the same, we divide the numbers. Again, that comes from the exponent property. When you're dividing exponential expressions and the bases are the same, you subtract your exponents. So since logs are exponents, if we're subtracting exponents, we can rewrite that as log of division. So 40 divided by 5 is log base 2 of 8, and that's equal to 3. If we do 2 to what power is 8, we get 3. One thing to be careful of with this second property, I'm going to do that over here, what several people do, and this is, I'm going to make this mistake so you hopefully you don't make the mistake. You have log, we'll use the same numbers, log base 2 of 40 minus log base 2 of 5. This does not equal log base 2 of 40 divided by log base 2 of 5. That's a mistake I've seen a lot of people make, and that's not correct. The two logs being subtracted become one single logarithm where the arguments are divided. So don't write it as log divided by log. It's log of the argument, in this case 40, divided by the other argument, in this case 5. That gives us a log base 2 of 8. So adding logarithms, you can rewrite it as a product. Subtracting logarithms, you can rewrite it as a quotient. And if you're multiplying a number times a log, and this is actually a very, very key rule here, we have a times log base b of c, that coefficient, that a, can become an exponent. So we can rewrite this as log base 3 of, log base 3 of 27 to the 1/3 power. There's a couple different ways to evaluate this. If we do 27 to the 1/3 power, remember fractional exponents are radicals. That's a cubed root of 27. That ends up being just 3. Cubed root looking for sets of 3 of the same number. So 27 to the 1/3 is 3. This becomes log base 3 of 3, which is just 1. Again, that says 3 to what power is 3. So we end up getting just 1 for that one. Again, the other option here, we could come from here and on 1/3 times log base 3 of 27 is 3, which also gives us 1/3 times 3, which is 1. So we can put several of these properties together in one problem. And when you're doing these, make sure you use your order of operations. So adding and subtracting, do left to right. So these, since we're subtracting, we can make that log base 9 of 108 divided by 4 is 27 plus log base 9 of 3. Now we're adding, so we can multiply log base 9, multiply the 27 and the 3, gives us 81, and log base 9 of 81 is 2. Remember that says 9 to what power equals 81. Here on the left side we have 3 times the log base 5 of 2 plus log base 5 of 4 equals log base 5 of x. Again, multiplication comes before addition, so we're going to take care of this 3 log base 5 of 2 first. And remember, coefficients become exponents. So 2 to the 3rd power is 8, so we have log base 5 of 8 plus log base 5 of 4. And since we're adding, we can multiply the arguments. Log base 5 of 8 times 4 is 32. And this is still all equal to log base 5 of x. So then x must be 32. And that's another property of logarithms, where if you have 2 logs with the same base and the same argument, we'll call it x. So 2 logs, and the base is the same, then the arguments have to be the same. That's what we're using here. We have log base 5 of 32 equals log base 5 of x. X has to be 32. Go through a few more examples. Again, take care of multiplication first, just like when with order of operations, multiplication and division come before addition and subtraction. So we're going to have log base 8 of 8 to the 1/3 power minus log base 8 of 2 to the 4th power. So 8 to the 1/3, remember, is a cubed root of 8, which is 2. So we have log base 8 of 2 minus log base 8, 2 to the 4th power is 16. We are now subtracting, so we can divide 2 divided by 16. And 2 over 16 reduces to 1/8. Now this is 8 to what power is 1/8. Well, remember 1/8 we can rewrite as 8 to the negative first. So this is equal to -1. We'll do a few more here, and that'll be it for today. Here, again, we're adding. Bases are all the same, so we can simply multiply the arguments. 2 times 3 is 6. You could do this all in one step if you wanted to. I'm showing it step by step. And then we have log base b of 6 times 5 is 30. That's called condensing them. We went from 3 logarithms condensed into one single logarithm. We can go the other way also. I'm going to skip down to 4 where it asks us to expand. So since that's log base 3 of m to the 4th times n, we can rewrite that as an addition of logarithms. And then that 4 as an exponent can become a coefficient. And there, all we're doing is simply expanding it using the properties, kind of going backwards from what we're used to doing. Here, bases are the same. 6 and 5 are being added. The log base b of 6 and log base b of 5 are being added, so we can multiply those. Again, just to go left to right. Now we're subtracting. Bases are the same, so we can divide the arguments. 30 divided by 2 is 15. And here, coefficients can become exponents. Log base b of r to the 1/2 plus log base b of s to the 1/2. Now we're adding. Bases are the same, so we can multiply the arguments. R to the 1/2 times s to the 1/2. And that's essentially it. So your primary 3, maybe 4 properties of logs. If the bases are the same and you're adding logarithms, you can rewrite that as one logarithm, same base. The arguments are multiplied. If you're subtracting logarithms and the bases are the same, you can rewrite that as one logarithm. The arguments are divided. Coefficients of logarithms can be written as exponents. And the fourth one we kind of looked at today is if 2 logs have the same bases and they're equal, then the arguments have to be equal. So those are the primary laws we're going to focus on. We'll do some practice problems with those today. Tomorrow and probably Friday also. So these can get a little bit involved, but those are the basic properties. Just take them step by step, one at a time. Okay, I will see you, quote unquote, see you soon. Hope you guys are doing well.